Welcome back to Learning with Merit. Today we're going to talk about Python operators. So covered in this video, we're going to talk about concatenation, which we use to combine strings, casting in order for us to change our data type, arithmetic operators, which are math operations, relational operators, which are inequalities, and then logical operators, which are not, and, XOR, and OR operators, which may be new to you, since they have mostly been used in programming. So first of all, we are going to talk about concatenation. Concatenation is a fancy large word that really just means to combine something. So we're going to combine two strings with the plus operator. So here I'll show you. These are two string literals. So this is a literal string because it's in quotes, literal string in quotes, and we use the plus operator to stick them together. So if I did print hello plus world, right there, it should concatenate them for us. So let's take a look at this in the test file and hit run, and you see hello stuck right next to the word world with no space. They were joined together. That's concatenation. Pretty simple. We can also use variables. We don't have to just use literals to do this. So variables, for example, we could use a equals hello and b equals world and then print a plus b. Check that in the test file. And here we got the same exact thing. So hello smashed together next to world. That's pretty much it for concatenation. It's a pretty simple concept, just sticking two things together, and you can chain it together as many times as you need to. Sometimes you can even chain together literals and variables when needed. Next, we'll talk about casting. Casting refers to changing the data type. So here we have several little functions, much like the print function we've used before, to help us understand something. It has a name and then parentheses next to it. The first one is type, and this brings back to us the type of data that it's working with. So we give it a data type or a piece of data, and it will tell us the type. We need that just so that I can show you what the type is as we change things, because it may not always be obvious. String is going to convert to a string. Int is going to convert to an integer, and float will convert to a float. Let's take a look at an example. So here in our test file, we have several different variables. A is going to be 5, B is going to be 10 in quotes, and C is going to be 7. So A is an integer, B is a string, and C is an integer as well. So if I print all these out, I get int, string, int. Makes perfect sense. Those are their types. But let's see what happens whenever I change those types. So here we have A equals string 5, B equals int 10, and C equals float 7. So now when I print the type of A, B, and C, I should see string, int, and a float. And I do. I see string, int, and float. Sometimes we need to change the data type that we're working with, and there are lots of different reasons for this, and they come up periodically. A lot of times we need to convert a string number to an integer, and lots of times we need to convert an integer to a string so that we can use it for text, for example. So those two conversions are very important. Float will sometimes come up as well, depending on what you're trying to do. But converting back and forth makes it easier for us to do different operations. So that's casting, or changing changing your data type. I'll even add that there. Changing data type. Oops. All right, let's look at our arithmetic operators. There's a lot going on here. And it follows PEMDAS from any math class you've probably ever had. So PEMDAS is please excuse my dear Aunt Sally, or there's lots of other acronyms for it, but parentheses, exponents, multiplication, division, addition, subtraction. And this comes from hopefully any algebra class that you've ever been in. Here are the symbols we use in Python. We use a plus, a minus. Our multiplication symbol is different. We use an asterisk or a star or whatever you want to call it. It is right next to the 8 on your keyboard. You hit Shift 8, you get the multiplication sign. The / is our divide sign. And then two special ones that you will see come up. We have the parentheses, or not parentheses, excuse me, the percent symbol for something called modulo, also known as the remainder. So sometimes we actually need to use the remainder in our functions. And then a double asterisk, or a double multiplication symbol, is used for exponents, or powers. So here we have some examples. Go to our test file. Here is addition, subtraction, multiplication, division, remainder, or modulo, and exponents. And we should get 7, 3, 10, 2.5, 1, and 25. And that is exactly what we get. Notice here that 5 divided by 2 gives us a remainder of 1. And that is why the answer is 1 and not 2. All the rest should be fairly self-explanatory. It's just math or arithmetic that you've done in other classes. So those are our arithmetic operators. We also have relational operators. Relational operators are better known as inequalities. So we take a look at these. Relational operators are used for our comparisons, and they always evaluate to something called a Boolean, and Booleans are those true or false values. So of course we have greater than, less than, greater than or equal to, less than or equal to, and not equal to. The ones you have not been used to are probably going to be not equal to with the exclamation point equals. The rest of them should mostly make sense. Of course we can't use an underline, so we have to use the greater than and then an equal sign. The single equal sign already is taken up as our assignment operator for like when we use a variable and we say a equals 10, for example. So in order to compare two things, we use two equal signs to make it clear to the computer what we want to do. And then special to Python that you probably haven't seen before in a math class, we have is for identical to, is not for not identical to, in to check if something is a part of something else, and not in to check if it is not a part of something else. All of these relational operators are used for comparisons, and they always evaluate to a Boolean. That is very important to remember. Here we have a couple of examples we'll do in our test file. So here I've got x equals 50, y equals 45, and z equals 45. And we've got some different comparisons there. We check if x is greater than y, that should be true. X is less than y, that should be false. X is greater than or equal to z, that should be true. Y is less than or equal to z, that should be false. Y equals z, that should be true. And then y is not equal to x, that should also be true. So we check those, and we get true, false, true, true, and that is exactly what we expected. Let's take a look at logical operators. These should be new to you. Logical operators also have their own form of PEMDAS, although you've probably never heard this one before. In Python, the PEMDAS, or the order of operations for logical operators, is not, and, XOR, and OR, or you could call it NAXO if you wanted to. Here are what we use. We use the not keyword, We use AND, we use XOR. XOR is actually not a keyword in Python. You can't really use it, but you can use this bitwise operator there. And then we've also got OR. NOT gives you the opposite. AND requires both things. XOR means only one. And then OR means one or the other. So to look at this, we need something called a truth table. Truth tables show how these logical operators are evaluated. So for NOT, it's fairly simple. We've got not true and not false. Not true is false, and not false is true. It is the simplest truth table. If we want to look at a couple of examples here, we can go to our test file. So here we have A equals 5, B equals 2, C equals 8. And then we print not C equals 0. Now the weird thing is it actually checks this first and then says not that. So C is greater than 0. It is, so not true, we should get false. And then we've got the same thing but with the other symbol for not. And we get false both ways. Our next one we need to look at is going to be an AND truth table. So if we take a look at an AND truth table, it looks like this. So AND, if both things are true, true and true, we get true out. Everything else is false, 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 false. So if we have at least one thing false, everything is false. We have to have both trues for an AND. For an XOR, we use the little, it's called a circumflex. It is right next to the 6 on the keyboard. Only one thing can be true, not both. So it's only true here in the middle. One thing is true and one thing is false. That is our XOR. If both things are true, we get a false, and if both things are false, we get a false. We call that an exclusive OR. And then finally, we've got just the OR truth table. The OR is only false when both things are false. So as long as one thing is true, doesn't matter, it is true. So true and true, true, true or false, true, false or true, true. Only when it's false and false do we get false out of an OR. So I've got some examples for all of these. So we need to grab our numbers. So there are our numbers. Let's take a look at an AND. We'll take a look at an XOR. And we'll take a look at a couple of ORs. So we expect true from this one, true from this one. Actually, we expect true from all of them. So here we have A is greater than 4. That's true. C is greater than 10. That's actually not true. So we do, instead of this one, we would expect false. Let's make sure that's correct. And then we've also got true and false. We would also expect false from that one. Got to make sure all these are right. Then B is greater than A. Is B greater than A? 2, it is not. It is false. Is B greater than or equal to 2? It is, so we've got a false XOR true. We would expect a true. Is A less than 4? It's not. Is B greater than C? It's not. So we should change this to false or false, and we would expect false on that. Then we've got a less than 4. It's the same thing, so we should say false or false. So now that we've actually went and checked these, now we see what we would expect. Let's make sure that's all right. Ooh, let me check what I've got here. B is greater than or equal to 2, which is true. It is equal to 2. And then we've got B is greater than A, which is false. So we need to do one thing, add a couple parentheses here, and let's make sure that everything's working correctly. Order of operations can certainly mess us up. There we go. So now we got false, false, true, false, false. Just like we expected. Now this leads me to a good point. If you're ever unsure, just use parentheses. Parentheses will override everything in the PEMDAS. Right? So instead of order of operations, we can just use parentheses to make sure that everything is correct. But it is certainly good to know your order of operations. So if we come down here and we talk about combining logical operators, we've got a good example to go with this. It can get confusing, especially when you've got quite a few, like we've got an and another or and another and, but it's a little simpler if you use parentheses, like this right here. So now I can see I need to check this one, and I need to check that one, and then I need to see if it's true. So if this whole thing ends up being true, that whole thing ends up being true, then the whole thing should be true. If one of them is true, is one of them false, the whole thing is true. Okay, we're still following the whole or example here. So use those parentheses to help you, okay, break up your code and make it a little more readable, because this can be kind of confusing, and you may not even be sure, does it check the and first or does it check the or? Well, we should know from Naxo that it's going to check the and first every time, because order of operations. But we wouldn't want to get caught in a point where it checks the and first, and that's not what we wanted. So remember, parentheses overcome everything. Last thing we're going to add here is our general order of operations. Arithmetic operators always come first, and they follow PEMDAS. Then relational operators, which follow left to right. And then logical operators, which come last, but follow Naxo, not and, XOR, and OR. Hopefully this gave you a good introduction to operators. Remember, we talked about concatenation to combine strings. We talked about casting to change our data types. We talked about math operators or arithmetic operators. We talked about relational operators or inequalities. And of course the special operators in Python. And then we talked about logical operators, not and, XOR, and OR. Thanks for watching.